We will introduce contents related to the thermocouple in this video. Thermocouple is a commonly used temperature measuring element in temperature measuring devices, which can directly measure temperature and convert the temperature signal into a thermoelectric electromotive force signal. The principle used for temperature measurement by thermocouple is the Seebeck effect, also referred to as the first thermoelectric effect. It was discovered by Thomas Johann Seebeck in 1821, specifically expressed as the thermoelectric phenomenon causes a voltage difference between two substances due to the temperature difference between two different electrical conductors or semiconductors. Thermocouple is characteristically composed of a thermal electrode, an insulating sleeve, a protective tube, and a junction box. The thermoelectric electrode is its key temperature measurement module, which consists of two metal wires. The end that is joined together is referred to as the working end, measuring end, or hot end. The other end is called the compensation end, free end, or cold end. The hot end is placed close to the measured object during measurement, and there will be a voltage difference between the two metal wires on the cold end to obtain the temperature of the object. So how is the voltage difference generated? When one end of the conductor is heated, free electrons in metals are heated to obtain energy, and due to the influence of the temperature gradient, it moves towards the lower end of the temperature. Free electrons then gather at the cold end, causing a voltage difference between the two ends of the conductor. Thermocouples use two different types of metals. This is because the number and migration rate of free electrons in different metals are different. In this manner, a voltage differential between the two kinds of metal wires on the cold end may be produced. If the same metal is used, a voltage difference cannot be generated at the cold end. We should note that the terms hot end and cold end simply refer to the various settings in which thermocouples may operate. During measuring, the temperature at the hot end does not necessarily need to be higher than the temperature at the cold end, and the thermocouple's voltage differential signal is quite tiny, no more than 55 millivolts. However, the voltage signal that ADC can accept is around 2.5 volts to 5 volts. A high-gain amplifier is required to amplify the signal of the thermocouple to a level suitable for ADC. We assume that the voltage difference between the cold and hot ends has been attained, but what we focus on is the actual temperature at the hot end. In that way, we need to know what is the temperature of the cold end. Then, compute the temperature compensation. The actual temperature of the measured object can be obtained. In this case, the temperature of the cold end can be obtained using a temperature sensor, such as RTD. Through a large number of experiments, people obtained 8 thermocouples for common use. These thermocouples have their respective advantages, such as thermocouples of B-type, R-type, and S-type. The measurable temperature can go up to 1,800 degrees Celsius. However, they use the precious metals such as platinum and rhodium. The cost of use is relatively high. The most commonly used kind of thermocouple is the K-type. Although the high temperature features are poor, only up to 1,300 degrees Celsius are available. The use of nickel-chromium and nickel-silicon alloys has relatively low cost. During temperature measuring, the thermocouple is the same as RTD. Through a simple linear equation, it does not reflect the temperature situation of the thermocouple clearly. So people conduct the experiments to draw the temperature reference table of the thermocouple. In this manner, we may ascertain reasonably accurate temperature values of the thermocouple under various thermopower. Next, the thermocouple module will be used to complete the pertinent tests. The experimental equipment used includes M2101 Thermocouple Data Acquisition Module, SDS1011 USB converter, and a K-type thermocouple. M2101 Data Acquisition Module is designed specially for thermocouples. It can better reflect the temperature information collected by thermocouples. Specifications regarding modules and converters can be got in the M-series video. Next, we will connect the equipment. First, Combine the M2101 data collecting module with the SDS1011 converter. Then, connect the red wire at the cold end of the thermocouple to the in0 plus end of the M2101. Connect the green wire to the end of in0. Connect the Versus Plus and the GND of the converter and module distinctly. Connect the 485A and 485B ports of the two equipment separately. Finally, connect the SDS1011 converter to the computer through a USB wire. Run the data acquisition software and search for the equipment to enable the data recording function and currently in use ports to the task list. Click Run for data acquisition. You can then see the collected temperature information. Place the thermocouple in hot water, and the temperature displayed in the software will increase rapidly. Stop data collection. Zoom in on the canvas to see changes in the data more clearly.